Hi, hello. All right, we're gonna be doing 10-2 here with Excel again. So um, let's see, last time we walked through a titration of a strong acid, strong base. And there's three regions, right, before the equivalence point, the point exactly at the equivalence point, and then after the equivalence point. We walked through like what you're gonna calculate for each of those. And so I want to use Excel now to do this and to essentially recreate table 10.1 and figure 10.1 on page 209. First, we're going to do it as if these three regions are separate, and then we're going to talk a little bit about how to set up one sheet without having to take into account the different regions. As we'll use some logic to do that. But first, we're going to follow the exact same problem we did before, the problem outlined in table 10.1. So it's the calculation of the titration curve for 50 milliliters of 0.02 molar base, KOH, treated with 0.1 molar HBr. So let's first kind of get some things labeled out here for ourselves. Okay, so starting base amount, and I like to make spots for these things so that when we want to make a change, we can just change one number and the whole thing will adjust, right? So here's the problem is we have 50 milliliters of a 0.02 molar base, and so we can see that those two numbers are here. There we go. And so then I also want to calculate the moles of OH. And I'm going to do that by taking the volume times concentration. But we have in milliliters, so if we want to get that into moles, oops, that should be 1,000. We need to divide by 1,000, so there we have moles of OH. Then I'm going to titrate with strong acid. So again, we're just kind of getting everything lined up. And here we know the concentration is 0.1. So I also want to find the equivalence point. Oh, I should mention here at the beginning, I'm not going to ask for this Excel file from you, but I mean you should follow along, and so that at the end you have one for yourself. Okay, so how do we find the equivalence point? That's when we have the equal number of moles, right? And so we want to have this moles right here of acid. So if I take moles divided by the concentration and then times 1,000, that will give me the volume of acid needed to reach the equivalence point. Okay, now we're all set up, and I'll get my headings here. Just trying to think about all the things that we're going to need to know when we do this, right? Basically, we're going to start with acid added, and for now we can just kind of go by 1 milliliter at a time. By the way, if you type in 3 numbers and then highlight all 3, you can drag the corner. You can see it'll go up by 1 each time. So remember, we're going to have these different regions before the equivalence point. So anything up to 10, we're going to be looking at the unreacted or excess OH minus. So continuing across with our parts here, we're going to want to know the moles of H plus added. I like to center and bold things here. And then from that we'll get moles of OH minus left unreacted. Concentration of OH minus in molarity. Look at that, it learns, so it's centering and bolding things for me. And then I'm going to leave 2 blanks and we'll go pH. Okay, so as you know, here we're going to use Excel to just fill in stuff for us to make it easy. So the total solution volume changes as we add acid. So we're going to make this equal to the amount added plus the starting volume. And I want to hold in cell 3, we'll do $sign. Now moles added is going to equal volume added times the concentration divided by 1,000, because we have volume in milliliters, and should be 0. Yep. Now moles of OH minus unreacted will be the amount that we started with minus the amount of H plus that we just added. And I want to make sure that when I scroll down, I keep the moles of OH minus right there. Okay, now concentration of OH minus is going to be the moles divided by volume times 1,000, because I have milliliters. Right, and so when we haven't, just this is good to verify, right? When we haven't added anything, these numbers here are all the same as these numbers. Okay, now the pH. We talked about this last time, that if it's based on the OH minus concentration, you can first find H plus if you want. In this case, we have OH minus, we don't have H plus, and so we can take 14 minus the negative log of OH, and so minus the negative log would end up being 14 plus, and it's going to be log 10 of concentration of OH minus, and we get 12.3. So also, if you look at table 10.1, we've just recreated the top row, and pH that we got is the same. However, I'm going to change it. So you can right click and go to format, or right here, format cells, and I want this number to have 2 decimal points. So there we go. Okay, if we've done the work right, we should be able to highlight the whole row and drag down, and fills everything in. Except we have these strange things here, right? What's this? I think referring to something wrong. I forgot to put I forgot to put $sign on A9, right? So what happened was when I scrolled down, it moved from here to here, and then error, error, then number, and then zeros. So I think that should be good. We'll do it again now. Yeah, that looks much better. And so we can see how things are changing, and our pH is going down, not by very much, right? It's not changing very much, and when we get close to the equivalence point, we're going to see quite a bit of change. So let's add some more points here. We'll do 9.5, and it's yours might do this, it might not, but it kind of learns that I'm making a table here, and so when I change this number, it automatically fills in the next row, which is cool. Okay, and so now we see the pH changing, and I'm going to go ahead and highlight this. I'm going to go cell, style, and I'll pick just a color, right? And this is region 1, right? Region 2 is when we hit the 10 mark. And it filled everything in for us, except we have an error, right? Because it's trying to take the log of this number. And so really we can just fill this in as 7. And I'm going to highlight this as region 2. And then going in next, past the equivalence point, volume is correct, the moles of H plus added is correct, but now we have a negative moles of OH minus unreacted, and that's not going to really work. And so now you'll see why we have these other two columns. For region 3, what we care about is the moles of H plus in excess. And then we can figure out the concentration of H plus with molarity. So now we're going to fill those in. And just how this was H plus added minus the moles of OH minus unreacted, what here we're going to do is basically the opposite. So it's going to equal the H plus added. I think I said that wrong before, sorry. Minus the initial moles that we had. And we're going to put a $sign there. And I didn't put the $sign. I put a percent sign. There we go. So it's just the opposite. And we could just, have taken this and given it a negative, but we'll do it this way. So now we have moles of H plus in excess. And to get the concentration, we're going to take moles divided by the total volume times 1,000. And I put 100. Okay, oops, 1,000. Now if I want to get pH, pH will equal the negative log base 10 of the H plus concentration. We're at 4.78, and if we look at the table 10.1, that's what we would expect at 10.01 milliliters added. So let's do 10.1, 10.10, 10.5, 11, 12, 13. We'll go up to 16. So some of them followed over and some didn't. So I'll just take this whole row here, drag it down, and everything filled in nicely. So here is region 3. So we had to actually change the way we did the calculations for each region. And next time I'll show how to apply one thing to all of them. But this works. It's a little bit more work. You have to know the equivalence point, so you know where to start adding higher frequency of points between 9 and 10. But that's okay. So now if we wanted to plot volume of VA, right? This is essentially what we would call VA. We're going to plot that against pH. So you can pick what you want or go to recommended charts, and it shows what they might look like. This is what we want, the scatter plot. And if I wanted to try to recreate figure 10.1, it always gives you a little extra on the x-axis. I only want to go to 16. I'll show every 2. Yep, that worked. And on the y-axis, go from 2 to 13. Show every 1. And we now see that we have figure 10.1. We have the, I don't have the labels here. I guess we could do that. I kind of forget how to. I'm sure some of you know this kind of stuff better than I do. Labels, that might do it. Nope, that's just telling me where to put them. Add chart elements. Here we go. Axis titles. So the primary horizontal, the axis title will be VA milliliters. And primary vertical will say pH. And the title would be strong base titrated with strong acid. Okay, let's see if there's anything else we should add to this. I don't think so. Something changed. My vertical axis here. That's weird. That looks better. All right, cool. So the next video will be on my EduCreations whiteboard, and we'll walk through some of the logic, and then we'll come back to Excel again to create this on another sheet. All right?